The next word problem says that a 4,200 kilogram rocket and a 2,720 kilogram fuel tank are initially stationary in space. The fuel tank then separates and moves forwards with a velocity of 3.1 meters per second. What is the recoil velocity of the rocket? So this is an example of an explosion, so go ahead and pause this, try to solve it, and when you're ready, unpause. So let's try to solve this word problem. The givens are 4,200 kilograms, that's a mass, and 2,720 kilograms is another mass. And you have, let's see here, 3.1 ms, that's a velocity, and we're trying to find another velocity. So this is not enough information, so let's draw out a picture to see what's happening. So what you have is an explosion, so there's going to be a before, and there's going to be an after. And then you have two things, you have a fuel tank and a rocket. So if you read the question, and they're connected initially, so this means that both objects before, well actually let's go back and read this to see what's happening. So you have a 4,200 kilogram rocket, so the rocket has a mass of 4,200, and a fuel tank has a mass of 2,700. I'm going to call it fuel tank MA for tank. And so you have the fuel tank and the rocket, and it says, if you read lower down, it says that the tank separates and moves forwards at 0.31 meters per second. So I'm going to make the fuel tank here, MA, and this is going to be the rocket, MR here. And so before the collision, both objects are connected and stationary, so that means that the initial velocity before the collision is 0. And after the collision, there's an explosion, or a bang, and the tank moves forwards with the velocity, and that is a 3.1, so that's going to be V tank final, or VA final is going to be 3.1, so this is VA final. And what we're trying to find is the velocity of the fuel tank, velocity of the rocket after the collision, so we're trying to find VR final. Okay. So now, applying conservation of momentum, this means that the total momentum before the collision, which is going to be mass total multiplied by V initial for both objects, is going to equal mass rocket multiplied by V rocket final plus mass fuel tank multiplied by V fuel tank final. Luckily, the initial velocity is 0. So that means that this is 0, and we can just cancel out the left side. So you get that 0 is going to equal mass rocket multiplied by V rocket final plus mass fuel tank multiplied by V fuel tank final. And so here we can plug in. So mass rocket is going to be 4,200. We're trying to find the velocity of the rocket final. And mass fuel tank is equal to 2,720, and fuel tank final is 3.1. And doing the algebra, you get that V rocket final is going to equal minus 2,720 multiplied by 3.1 and divided by 4,200, and that gives you the final velocity of the rocket being minus 2.01 meters per second. Okay, so let's try this one. It says a pool ball is initially moving with a momentum of 50 kilogram meter per second. It is then hit with an impulse of 25 kilogram meter per second for 0.0031 seconds. A, what is the force on the ball? And B, what is the final momentum of the ball? Okay, so go ahead and pause, try to solve this word problem, and when you're ready, unpause. Alright, so let's write down what's given. So we have 50 kilogram meter per seconds. So that's the momentum. And we have 25 kilogram meter per seconds. Momentum, impulse, that both have the same units, but in this case here, this is an impulse. And we have 0.0031 seconds. So this is the time. And part A, we want to find the force. And part B, we want to find the final momentum, P final. So let's just try to draw a picture to see what's happening. So you have a pool ball. It has some initial momentum, so it has a momentum P initial. And it's hit with an impulse, so there's a force or an impulse that is applied to it. So there's an impulse I that's applied to it. And what that's going to do is it's going to make the ball speed up so that it's going to have a new momentum P final. And so part A, we want to find the force, and part B, we want to find the final momentum. So there are two equations to apply. The first one is that impulse is equal to force multiplied by time, and the other one is that impulse is equal to final momentum minus initial momentum. So we'll use the first one first. So we're going to use impulse is equal to force multiplied by time. So we're given the impulse. It's equal to 25. We're trying to find the force, and the time is 0.0031 seconds. So then the force is going to be 25 divided by 0.0031, and that'll give you 8064 newtons. Alright, so that's part A. And part B, again, we have the impulse. It's 25, and we're trying to find a final momentum. So we're going to use the equation impulse is equal to final momentum minus initial momentum. So the impulse is 25. We want to get the final momentum, and the initial momentum is equal to 50. So then the final momentum is going to be 25 plus 50, which is going to be 75 kilogram meter seconds.